All right, so to demonstrate what we mean about what's going on with these threads, right, so remember that we go through, we get location, reverse geocode, and then we go ahead and save that out. And if you remember the implementation we have here, just for demonstration purposes, right, and each one of those methods, we call simulate delay, which puts a 3-second delay in each operation, right, to simulate something being long running. That means to go through those 3 steps takes us a good 9 seconds, or maybe a little more by the time we put some overhead inside of it. Right, so what that means is that if this code is actually running on the main thread, as we think it is, our user interface will actually be locked up, just like we were doing it right inside of the menu handler itself. Right, so let's see what happens when we run this, and we take a look at it in the emulator. All right, so here we are running in the emulator. So click Menu, and you notice when I click Do Work, it highlights, and yet the UI doesn't do anything. Right, so we've gone through all the trouble to run this in a service, yet we're still having the exact same problem we had when we ran it directly in the menu handler. Right? And that shows us that what we need to do is in our service, go ahead and launch the background thread. Remember that the purpose of the service is not to magically run things in the background for us. The purpose of the service is to tell the operating system that I'm going to do some work in the background that's still important. Right? Don't make it a candidate to be killed. Right? We still are responsible for doing that work in the background. As we mentioned, we're going to use this executors class to go out and find classes for us or implementations for us to actually let us do things like work in thread pools. Right? If you take a look down here at the methods that are available, we'll see that there are a number here. Notice there's something like new fixed thread pool, new scheduled thread pool. One I like here is new single thread executor, right? New single thread executor, right? That actually allow us to kick some work off in the background. Right, and that's what we'll go ahead and use. We'll go ahead and use that new single thread executor. And notice it returns back to us an executor service. If we take a look at executor service, right, that's the reference we're going to use to actually submit work to it. If you notice here, there's a little code example that just shows, well, you go out and get a thread pool. Right, that gives you back your executor service. And you can just call execute. There's actually a number of different methods on this. There's one called execute, which just goes ahead and runs something in the background. There's another one called submit. They'll actually run something in the background and give you back a future reference so you can actually wait for its completion if that's important to you. In our case, we just want to run things in the background. So all we're going to do is get this single thread executor and then go ahead and submit work to it. Okay, so we're back here in our service class. Right, so what we want to do now is go ahead and have a reference to that executor service. So we'll go ahead and just declare one of those. Now again, we want to go ahead and create that in our onCreate method, right? We're going to do that when we first start up. So we'll just say executor service equals executors. And the one we want is the new single thread executor. And so that basically gives us a single threaded thread pool. So we can keep just giving it work to do, and it will go ahead and run that work for us on the background thread. Right, so the way we do that, of course, is that now each time we get an onStart command, we're going to go ahead and submit some work to him. So we'll just say executor service. And what we'll use is its execute method, which goes ahead and runs something in the background. It needs a reference to a runnable. So we'll say new runnable. Right, and all we need to do now is put all of our work inside of here. So go ahead and grab all that. Paste that into the body of our run method. Oops, actually I grabbed one line too many there. Because we still want to return the service start not sticky from the actual onStart command, but we're now going to do all of our work here inside of runnable. All right, so now we have a proper service. Right? When the service is first created, we go ahead and create our single thread executor. And now for each work request, we just pass the work to be run into the background thread. Right? So now when we go ahead and run this, it should actually behave correctly, right? So the user interface should become responsive immediately because the only thing that actually runs on the main thread is the request to do some work. The work itself runs on the background thread inside of that thread pool we created with the executors reference. Okay, so now if we click Menu, we click Do Work, it responds immediately, just like we expect it to. Right, so just to prove that the work itself is actually happening, though, we can go back to the source code. Put a breakpoint in here. Now go ahead and say Menu, Do Work. Again, UI responds. We jump back here, and now we're back here in our thread. Right, we're stopped inside the work there on our background thread doing the actual work, and that's what we want. So basically, this shows kind of the more general way that we implement a service of we've got our on start command, but we're going to hand that work off to some kind of thread, generally a thread pool returned back from using the executors class.